Hello, so we are going to continue the journey about the sequential function charts. This is the part 3, and in this video we are going to address the following. First, we are going to speak about interpret parallelism. Then we are going to speak about the AND distribution and the AND junction. Then we are going to move to structural parallelism, and then we are going to provide an example about structural parallelism. So, what is interpret parallelism? Is when the evolution is determined by the transition conditions associated with the enable transition. So, consider this example, and if step 2 is active, imagine here, this I'm going to put it here. It means that transition 3 and 9 are both enabled. So, if they are true, or they assume the logical one at the same time, it means that this token is going to be removed from step 2, and a token is going to be inserted in step 3 and step 8. So we start the simultaneous evolution of sequence 1 and sequence 2. Okay? This is why it is called interpreted. Okay, so we got these notions and distribution and junction. So if we got one step connected to one transition, and the transition got as input output 1, 2, 3, in this case steps, we need to use this double line, which is called sometimes distribution, and also sometimes synchronization. That means that when step 2 is active, if this variable becomes true, it is the transition, it is cleared, and this mark leaves this step, and we got a mark or token in each one of this of step 5, 12, and 21. So when transition 30 is clear, we got the simultaneous activation of step 5, 12, and 31. So that's why this is called sometimes the AND distribution. And we got the same thing when you got several steps connected to the same output transition, which is this case. In this case, we need also to use this double line, which it is called a junction, and sometimes also synchronization. And in this case, we have to have all three steps, this one, 12, 7, and 43, active. So this is the transition 22 is enabled. If it is enabled, when it passes to the logical one, it is cleared, and it means that this token, this one, and this one give the steps, and then we got a token in step 77. So this is also called, as I mentioned before, synchronization of sequences. Okay. So we are going to see this is called also structural parallelism, and we can see here an example where two parallels, where in this case the evolution is determined by the structure of the diagram. So we are going to see one example about structural parallelism, which is in the example 3 of e-GRAFCET plus. So I'm going to just provide the example. In this case, the example is we have two cars in two separate tracks. So we got car C1 or trolley C1 in position A, which is the initial position and the resting position, and C2 in position C, which is also the initial position and resting position for trolley 2. So we got sensors detecting if the trolley 1 is in the A or in the B position, and also sensor C and D for detecting the position of the trolley C2. We got these actuators to turn the motor to the left or to the right to each one of the cars. So this is the system, and so these are the inputs. We got also a button which is going to start the movement for the two cars at the same time, and the sensors, and the four outputs for controlling the motor's direction. So this is one of the solution for this problem. So we can see here that this is the initial step 0, which means that both cars rest, C1 and C2. So when the button P is pressed, this transition, which is enabled, is going to be cleared, and we got this mark leaves this position, and we got the simultaneous activation of step 1 and 4. So this is going to start the movement of the cars in this direction. C1 is going to move towards B, C2 towards D. And okay, so imagine that the C1 is faster, and it is going to reach the position B before C2 is in the mid journey. So when it reaches this position, so it means that it reached this B. So this token leaves step 1, it appears in step 2. So we activate the motor to the other direction, and it may reach that position A. When it reaches the position A, then we got this step active. So in this point, it means that the car is still moving, car 2 is still moving towards D, and car 1 has finished the cycle. However, even if this, okay, we got this synchronization, even if this condition is 1, this cannot be clear because it is not enabled. So that's why these steps are called waiting steps, because it forces to wait for the other step, or in this case for the other car to be in the initial position. So only when this reaches this point, this token passes to this step, and then it inverts the movement and it reaches this position. Then in this instant is this transition 6 is clear, and so we got step 0 activated at this point. I'm going to show you this simulation in e-GRAFCET class. So this is the structural parallelism. It is this one. So we are going to see that you can change here to put the velocity. In this case, I'm going to select identical velocities, and I'm going to press POP. So as you can see, they are both moving to the right and then to the left at the same time. So this is a perfect matching. You can do that step by step, and you see what happens. So they're moving towards this direction, and then they stop. This become true, and then the other direction. Okay, but then if I choose that C1 is faster, okay, now C1 is going to move faster than C2, and you can see that he's going to reach the mid journey half of the cycle before in B. As you can see here, B is going to be 1, and C still didn't finish. So if I continue, it's going to finish the journey before C1. And okay, so at this point I got step 3 activated, but C1 must wait for C2 before, if I press this, is not going to start another journey because I have to finish the journey from C2 before I return to the initial step 0. So this double line, this synchronization, this junction forces that both steps are true. Okay, and so you can also try with C2 faster, and this is quite important to understand why we need. It is important to understand why do you need waiting steps as well. Okay, and with this you have also some different implementation of this, but in this case I'm going to stop the video here, and you can play around with the animations. And okay, thank you for your attention.